Hi, and welcome to our fourth objective here in chapter 30. And what we're going to do today is we're going to look at take that classical dichotomy, prove it according to the quantity equation, and look at some of the nuances of it. So it's a little bit longer lecture than I normally do, but hopefully it'll work out just fine. So let me go ahead and share my screen with you. Okay, so we're going to explain the quantity theory of money. So we talked a little bit I talked a little bit in the intro about the velocity of money. And this is the rate at which money changes hands. It's approximately 3 currently. And if we want to see exactly how to calculate velocity, it is the price level. Remember, that's the consumer price index. So the CPI times GDP. You'll notice that the CPI times GDP will give you nominal GDP divided by the money supply. So if we look at this, we can rearrange the equation. So I just gave you the equation in the previous slide. Velocity is equal to the price level times GDP divided by the money supply. If we cross multiply this, okay, so P times Y will come over here equals velocity times the money supply. So just to reiterate, the consumer price index, GDP, real GDP, velocity, and the money supply. Okay? Now, this is the quantity equation. All right? So you'll see it listed up here as well. Now, one of the things we know is that velocity is relatively constant. We're going to prove that in just a moment. We also know that inflation is relatively constant as well in the United States. So if I isolate those two variables, really what we see is the money supply, GDP, and we might see the money supply and inflation. Okay? So an increase in the quantity of money or the money supply, okay, must be reflected in the price level. The quantity of output must rise, or velocity must fall. So the dependence of this equation becomes kind of important. So let's go ahead and take an example. Here we have 1 good corn. The economy has enough labor, capital, and land to produce 800 bushels. Notice that is GDP, real GDP. So I'll put real GDP. Okay. Velocity is constant. The money supply is 2,000 and the CPI is $5 a bushel. So we want to compute nominal GDP and velocity in 2008. So I'm going to go ahead and do nominal GDP right here. Remember that nominal GDP is just the price level times real GDP. So if our price level is $5 a bushel times real GDP of 800, that gives us 4,000 is nominal GDP. Okay. Now I can go ahead. I'm going to do it on the next slide just to give myself a little bit more room. But we're going to go ahead and take that 4,000 and bring it forward. So remember, we said that nominal GDP price level times real GDP price level was $5 a bushel times 800, which gave us 4,000. So that's nominal GDP. Now, if we want to calculate velocity, what we're going to do is divide this nominal GDP by the money supply. Okay, and that's where I got that information right there. And if we do that, we get 2. Now, what does that 2 mean? 2 means that the average dollar is used in 2 transactions. It changes hands twice. Now, why would we want to know that? Well, we'd want to know that because this will tell us the speed with which monetary policy will actually come to fruition. Okay, so again, here's our answers. 4,000, we get 2, which means the average dollar was used in 2 transactions. We're now going to take this information and bring it forward. So remember, velocity we just calculated was equal to 2. Real GDP was 800. Nominal GDP, price level, times GDP, nominal GDP was 4,000. Okay. Now, let's say that the Fed increases the money supply by 5% to 2,100. Compute the 2009 values of real GDP and the price level, and then what's the inflation rate? Okay, so we can use the quantity equation here, and we can say, okay, if we have, again, that's the price level times nominal GDP is equal to velocity times the money supply. We've already calculated real GDP as 800. Price level was $5. So that gives us 4,000 over here. If we're holding velocity constant in what we just calculated, then we have 2 times 2,100. Okay, that means that this must be equal to 4,200. Now, 4,000 does not equal 4,200, so that must mean then that over here, this has to go up $200 to make it balance. If it goes up $200, then essentially what we're going to see is that it must be prices that have increased in this case. Okay, so now we're going to say, okay, if P, price level, times real GDP is equal to 4,200. We know that the price level, GDP does not increase immediately. So we would see that we have the price level times 800 is equal to 4,200. We're going to go ahead and divide each side by 800. And we end up with a price level of, and I believe it's $5.25, but let me double check. So we have 4,200 divided by 8. Yep, $5.25. So the new price level is $5.25. Okay, now we want to compute the inflation rate. And a lot of you got this wrong on the last test, so please make note of this. We're going to take the previous price level, that's right here. Let me do that in a different color to make it easier to follow. So we're going to take the previous price level of 5, the new price level of 525, and go ahead and compute that. So we take our most recent 525 minus 5 divided by 5 times 100 and express that as a percent. So 0.25 divided by 5 would be the price level has increased 5%. Now this is important because notice that the Fed increased the money supply by 5%. So what happened in the quantity equation is the price level went up 5%. If we say that velocity is constant and real GDP is unchanged. So those are the two kind of important pieces to this. Okay, so again, just kind of the workout that we looked at for A, we saw that if the Fed increases the money supply by 5%, then the effect, according to the quantity equation, will be that the price level will likewise increase by 5%. B, suppose technological progress causes real GDP to increase to 824. Now compute the inflation rate. So let me go ahead and work that out on this next slide. To take a look and bring forward the information, I'm going to go ahead and work out B for you here. Okay, Suppose technological progress causes the GDP to increase to 824 and then compute the inflation rate. So remember that velocity was going to be held constant at 2. Our previous price per bushel was 5. Our previous real GDP or nominal GDP was 4,000. Okay, so suppose technological increase. Okay, so let's go ahead with the quantity equation. And again, remember that's the price level times real GDP is equal to the money supply times velocity. Okay, so if we look at this, we're going to increase the money supply from 2,000 to 2,100. So essentially what's happening over here, if we're holding velocity constant, is an increase of 5%. Over here then, because this equation must be equal, we know that this is going to increase by 5%. But where's the increase coming from? Is it coming from inflation or is it coming from a change in GDP? Well, we can take a look at that. So let's go ahead and focus on the change in GDP first. Remember that our real GDP prior was 800. And our new GDP, I'll call it Y1, is 824. So let's take a look at the percentage change there. 824 minus 800 divided by 800 times 10 or times 100 to make it a percent. So if we take 824, subtract 8, divided by 8, we end up with a 3% change, an increase of 3%. So notice that this was 5%. So this must be equal to 5%. We know 3% is growth in GDP. So that must mean that 2%, or the difference, comes from the price level increasing. Okay. All right, so there's our answer to A. Let's make sure we got that right. And we did, inflation rate 5%, same as the change on the other side of the equation. If technological progress increases by 3%, then we can say, hey, look at what we've got, $5.10, or a 2% change in GDP, which means that if you take the 3% change in GDP, and a 2% inflation rate, add those together, 3 plus the 2, you're going to end up with the 5%. So what's the difference between these two slides? The difference between these two slides is that one focuses only on inflation. 5% increase in the money supply led to a 5% increase in the price level. In the second example, B, we had a 5% increase in the money supply, and that 5% on the other side of the equation was parsed out as a 3% growth in GDP and then a 2% increase in prices. Which is better? I would like B as well. So let me go back and share my next slides with you. Okay. All right, cool. Okay, so what's a summary of the quantity theory of money? And this becomes kind of the important. If real GDP is constant, then that was our first example of A. Then if we increase the money supply by 5%, we have an automatic 5% increase in the price level. If real GDP is growing, then what happens is, like in B, we had an increase of 5% in the money supply, and that led to a 2% increase in real GDP, I think, or 3%. Let me go back and remember precisely. 2%, okay. A 2% increase in GDP, there we go. Get that right. it was a 2% increase in the price level. Sorry, it's changing of slides. 2% increase in the price level in P, and a 3% increase in real GDP. So what happens? Economic growth increases the number of transactions. The demand for money increases, and this excessive money growth causes inflation. Okay, so this graph looks at nominal GDP, the quantity of money, and velocity. Notice that velocity is relatively constant. And this is why we like to say in the equation that if we look at the money supply times velocity is equal to the price level times real GDP, that what changes on the left side of the equation? Because velocity is relatively constant, what changes is the money supply. Now, if we don't have an offsetting growth in GDP, then that's all absorbed by the price level. If we have growth in real GDP, then you will see both variables, meaning the price level and real GDP increase, which is actually better. Okay, that's the end of this learning objective. If you have any questions, again, please don't hesitate to contact me. I'd be happy to work additional examples for you. Thanks for your time, attention, and have a great day.